Part 2 of Class 1, we are dividing radicals now. So, steps you can take, see if the numerator and denominator are perfect squares, and then simplify. See if you can divide the bottom into the top or vice versa, or simplify your radicals first, and then simplify your fraction, or rationalize. In the end, you need to rationalize your denominator if needed. Remember, you cannot leave radicals in the denominator. Okay, so looking at this first one, root 27 and root 12, remember that can be written like this. So you can simplify, 3 goes into each, 3 goes into 27 9 times, 3 goes into 12 4 times. We can divide it up, the square root of 9 is 3, square root of 4 is 2. So 3/2 is your answer. Alright, the next one cannot be split up, okay, cannot be reduced, So I'm just going to split it up and look at each one separately. 27, I know, can be rewritten 9 times 3, so that is 3 root 3. On the top, x cubed can be simplified. 2 goes into 3 once, so if you think about this, do you need to write this out every time? Probably not. Okay, 2 goes into 3 once, so that's your x squared, so I'm going to bring an x out with 1 left over, which means an x is going to stay in. Okay, and that is just here. Square root of x squared is x. One of them stays inside. Now, cannot leave a radical in the denominator, so I need to multiply top and bottom by root 3. So what's underneath stays underneath, so I have x root 21x over, now root 3 times root 3 is 3, times 3 is 9. So that is my answer. Yes, 3 goes into both 9 and 21, but 21 is underneath the radical, 9 is not. They cannot be simplified. So that is your answer. Okay. This one I'm over here, I think I'm going to skip. You can do that one. You know how to do that one based on these. This one right here, x to the 7th and 24. So again, simplify x to the 7th, simplify 24. So 24 is 4 times 6. So that's going to be 2 root 3, or 2 root 6, sorry. And then x to the 7th, 2 goes into 7 3 times, so x to the 3rd comes out, 1 left over. Again, if that confuses you, I just split that to x to the 6th times x. The square root of x to the 6th is x cubed, and then an x stays in. Again, that cannot be, or you cannot leave a radical in the denominator, so multiply by root 6. So on the top, you have x cubed, root 6x. On the bottom, root 6 times root 6 is 6. 2 times 6 is 12. So that would be your answer. Okay. With this one, square root of 25 is 5. Square root of 3x cannot be simplified. So this one has an x in the denominator. To rationalize, you're just going to multiply by that same exact thing, root 3x. So on the top, we have 5 times root 3x. On the bottom, root 3x times root 3x is just 3x. So that's it. Okay, that's 5, now 6. Alright, and finally, this one I can simplify first. X goes into x cubed, or when you simplify that, I'm sorry, 3 minus 1 is x squared. So I'd leave us x squared on top. So we have the square root of 3x squared over the square root of 2. We have to rationalize, and we also know that x squared, the square root of x squared is just x. That's going to be x root 3 over root 2. And then you have to rationalize, so multiply by root 2 gives you x root 6 over root 2 times root 2 is 2. Again, yes, 2 goes into both 2 and 6, but 6 is underneath the radical, so you cannot simplify that. Okay, so some more examples. Alright, this one right here, very simple. You just put it all underneath and reduce. Okay, you have the 3's reduced, the 5's reduced, 2 goes into 10 5 times, square root of 5 over square root of 1 is just square root of 5. Square root of 1 is just 1. Okay, that's it. So those ones, yes, they look difficult. They're not. Just combine everything underneath 1. Okay, same thing over here. Just combine it. 5 over 12x times x to the 5th over 15. We can simplify. 5 goes into 15 3 times. X to the 5th and x, we can cross out an x, we're left with x to the 4th. So what you're left with is the square root of x to the 4th over 12 times 3 is the square root of 36. Square root of 36 is 6. Square root of x to the 4th is x squared. Okay, so it's really much simpler when you combine them like that. Alright, this middle one, I'm going to simplify first. Okay, combine it all under 1. Okay, and then simplify. We have 3 goes into 12 4 times, 3 goes into 27 9 times. X cubed and x to the 5th means we have x squared left on the bottom. Y and y squared means a y left on the bottom. Z cubed and z means a z squared left on top. So I end up with doing the square root of 4z squared over the square root of 9x squared y. From there, simplify each one. I'm going to take this up here so we have room. The square root of 4z squared, square root of 4 is 2. Square root of z squared is z. Square root of 9 is 3. Square root of x squared is x. And we have a square root of y. So we do have to rationalize. Multiply by the square root of y. That gives us 2z times the square root of y over square root of y times square root of y is just y. So 3xy. No, we cannot simplify those y's. One's inside a radical, one's not. Okay, so that is it. Alright, this next one. I know that I cannot simplify 6. I can simplify 32. So, this one, totally up to you. You can multiply everything and then take your square roots, or you can simplify first. Sometimes it's easier to do some of it multiply, some of it not. Alright, for example, here I have the square root of y squared. Why would I multiply it? I don't need to. So I know that y is going to come out, and also I know that 32 is 16 times 2. Alright, so I'm not going to make that a bigger number. So what I can do here is I have the 7, and I have a 4 come out, so that's 28. I know the square root of y squared is y. What's still left inside is a 2 and an x. Now over here, I'm just going to leave everything as is. Because now when I multiply, I have 6 times 2, which is 12. I have x cubed times x, which is x to the 4th, and I have a y. So, from there, I have 2 times 28 is 54, and a y on the outside. So on the inside now, 12 is 4 times 3. Square root of 4 is 2. So I'll then have 54 times 2, which is 108. I have this y out here. And then square root of x to the 4th is x squared. And then I still have a y on the inside and a 3 on the inside. So square root of 3y. Hopefully you follow that of what stays in, what stays out. And again, you can do that in any order you want. If you want to do 2 times 7 is 14, and then do 6 times 32, x cubed and x, y and y squared, totally up to you, whichever way you want to do it. Okay? I kind of pick and choose what gets multiplied, what doesn't first, depending on how easy it is to simplify. Alright, this one right here, let me move it down a little. I actually, when it's like this, I do multiply those across on the top and then simplify everything. Alright, so what I'm going to have on the top here is 2 times 12 is 24. X squared times x cubed is x to the 5th. Y cubed times y is y to the 4th. On the bottom, the square root of 3xy to the 5th. So now I simplify top to bottom. They're all in the radical, so you can combine it. 3 goes into 24 8 times. So I have 8 on the top. X and x to the 5th. One of them cancels, so I have x to the 4th on the top. Y to the 4th and y to the 5th means I have one y left on the bottom. Alright. Now, I'm going to have to rationalize because I have the square root of y, so I know I'm going to multiply top and bottom by the square root of y. So, square root of y times square root of y is just y on the bottom. And then on the top, 8 reduces to 4 times 2, so that's 2 root 2. Square root of x to the 4th is x squared, so on the outside I have 2x squared. On the inside I have 2 and y. And that is that. I believe that was our last. Yeah, those are our examples. Okay, now from here, after watching the 2 videos on class 1, you should be able to do the worksheet 1 on radicals worksheet number 1. Okay, go ahead and try those. Like I said again, sometimes it's easier to simplify first. In terms of top and bottom, simplification in terms of fractions, and then simplify in terms of radicals. Sometimes it's easier to simplify radicals first and then simplify your top to bottom. So up to you, try them both and see what works best for you.